Hi, it's George. Welcome to a couple of special edition videos for Math 126. In this video, video 1 of 1 for section 4.1, we'll be looking at exponential functions. For section 4.2, we'll be looking at the number e. Section 4.1, section 4.2 are not part of the Math 126 curriculum. However, I think it's super important that you guys see this material. Especially if you're going to be going on to Math 181. If you're not going to be going to Math 181, Calculus 1, you probably don't need it. You're not going to need it the rest of the semester here in 126. You don't really need it for 127. But in 181, you're going to use it a lot. And so the fact that we don't really present it to you, I was doing some tutoring for 181. Some of the students, I was asking about these exponential functions, specifically e. Had no idea what I was talking about. They had never been presented the material. So that's what these two videos do. You can see they're quick videos. It's just a real brief introduction to you. What are the functions? What do they look like from a graphing standpoint? That's really our key. And so I just want to have you guys get exposed to this. So for section 4.1, this is about exponential functions. So in section 4, 3, 4, and 5, we're going to be talking about the log function, which we do use quite a bit here in 126. The reverse of the log is essentially the exponential. So let's look at a definition. We have that the exponential function with base a is defined for all real numbers by the following. We say f of x is equal to a to the x power. Exponential is what? That's our exponent, our powers. With two caveats. So where a has to be positive, it could be a fraction, but it has to be positive, and a is not equal to 1. Because if a is 1, our answer is always going to be what? 1. It's just going to be a straight line, a flat line. So the exponential function, if a is a positive number not equal to 1, is defined by that. And let's look at some examples of what it would look like if we tried to work this out. So if f of x is equal to 3 to the x power, then we want to find the following. So find a, which is f of 2, b, f of a half, and c, f of negative 2. So for a, remember when we have functions, what do? We take the number inside the parenthesis, we plug it in for x. So f of 2 would be 3 to the second power, which is what? 3 squared is 9. So you can see when you've probably heard the expression, it's growing exponentially. That's what they're talking about here. When x is 2, if our base a is 3, it's already 9. It's already getting to be a big number. So you can imagine as this becomes a 5, a 10, 100, 1,000, the numbers are going to be huge. For b, if I have f of 1/2, well, this means what? This means 3 to the 1/2 power. And so what do we know about converting exponents to radicals? Well, this is the same thing as the square root of 3, which is approximately about 1.7. 1732. So f of a half is 1.732. You know what? I'm going to throw one more in here. So let's call it d. And let's do d first. And d is going to be f of 0. So f of 0 is what? That would be 3 to the 0 power. Anything to the 0 power is 1. So you can see here that when my numbers, the x's that I was plugging in are positive, it's always a number going to be bigger than 1. When I hit 0, it's equal to 1. And how about if I do c, f of negative 2? Well, that means 3 to the negative 2 power. So again, using our exponent rules, that means what? That's the same as 1 over 3 to the positive 2 power, which is 1 over 9, which is about 0.11. So, what did we see here? Even though our x is negative, our answer is still positive, right? Because that negative doesn't mean it's a negative number, it means it's a negative exponent, which is causing us to take the reciprocal of that function value. So then next, and like I said, what I really want you guys to get from this is the graphs. Graphs of exponential functions, and for section 4.2, graphs of the function e to the x. So the next thing I want to do then is graph f of x is equal to 3 to the x power. So what does this thing look like if I tried to graph it? Well, if we plot a few of the points we already figured out, when f is 2, our value for the function is 9. So way up here. When x is a half, our value is about 1.7. So somewhere about here maybe. When x is 0, our value is 1, as it always will be if we don't have any horizontal or vertical shift to the function. And when x is negative 2, our value is about 1/10. So somewhere down here. So what does this thing look like? Well, as we pass 0, this thing's going way off to infinity. But as we get close to negative infinity, what happens? This graph gets closer and closer to 0, but it never actually hits 0, right? There's no value I can pick for x that will make this thing equal to 0, nor will it make it a negative number, right? Because it's a positive number to some power that's not going to ever turn it into a negative number. So this is what our function 3 to the x power looks like, and this can actually be generalized for f of x is equal to a to the x power if a is greater than 1. So if a is greater than 1, my base, it's always going to have this shape. It just depends how quickly it gets, how steep it gets right away. How quickly does it grow? But if a is greater than 1, it's always going to have that shape. What about if a is less than 1, but we know what? A always has to be positive. So let's look at one of those examples. If f of x is equal to 1/3 to the x power. So let's plot some points. F of 0 is still 1. How about f of 2? Well, f of 2 is going to be 1/3 squared, which is 1 over 9, which we saw in the last example is 0.11. And how about negative 2? If f is negative 2, that means it's 1/3 to the negative 2, which with our exponent rules is the same as if I flip what's inside, so 3 over 1, and make the exponent a positive number. So this is 3 over 1 squared, 3 squared is 9. So it did what? It flip-flopped what this thing looks like. So the graph of this one, also this should say graph. So this one's going to look similar to this graph. The only difference is because my value of a is a fraction, still positive, but a fraction, it flips it around. So it still goes through 1, but now it's going to be starting in the upper left and going towards 0 as I get towards infinity. And again, this is the general form, f of x, a to the x, if a is less than 1 and greater than 0. So if a is a fraction, that's what this graph will look like. No matter what a is. 1/3, 1/2, 1/10, 1/30th, whatever. If it's a fraction, this is what it'll look like. If a is bigger than 1, so 1.1, 2, 3, 10, 50, it's always going to have this general shape. So that's it. That wraps up the video for section 4.1, an introduction to exponential functions. Come on back and I'll show you a very specific type of exponential function in the video for section 4.2.